Hello dear students, the topic of discussion for today is analysis of fats and oils. So to analyze the fats and oils, we have different analytical constants or different analytical parameters. So these are the following constants: acid value, saponification number, ester value, iodine value, acetyl value and Richard Missel value. So in this session I will explain first three analytical constants. They are acid value, saponification value and iodine value. Let us discuss one by one. So acid value. So what is meant by this value or acid value or acid number? It is nothing but you are going to analyze the given fat or oil which is present in your sample. Suppose if the oils are stored for a longer period of time, what will happen? Decomposition will happen or hydrolysis of fats and oils will happen. So leads to the release of free fatty acids. So we are going to estimate the amount of free fatty acid present in the sample. So what you will have to do is you will take potassium hydroxide and react with the fat or oil. The amount of potassium hydroxide reacted is estimated in the reaction, and by the estimation of potassium hydroxide or sodium hydroxide, we are going to find out the acid value. So let's discuss in deep about the acid value. You can see here it is a measure of the free fatty acids present in a sample of oil or fat. That indicates hydrolysis of glycerides or hydrolysis of fats. So fats is missing here, you can write down. What happens in the reaction? You can see the reaction. There is an N with COH group, carboxylic acid group. When it reacts with sodium hydroxide, it will form a sodium salt of that fatty acid. So what happens? If it undergoes or if the fat contains any free fatty acids, that will be estimated. So this is called acid value. So nothing but the measure of free fatty acid, because when the fat is there, it's an ester. But when it is stored for a longer time, when it is pure, it will not release any free fatty acid. When it is impure, it will release the free fatty acid. So generally, acid value will determine the purity of fat or purity of oil by estimating the amount of free fatty acids present in the sample by reacting with either potassium hydroxide or sodium hydroxide. Okay? So principle involved here. It is defined as the number of milligrams of potassium hydroxide required to neutralize free fatty acids present in 1 gram of the fat or oil. So in 1 gram of fat or oil, how much or how many milligrams of potassium hydroxide is required to neutralize that fatty acid? This is the principle involved here. This acid value ranges from 1 to 5. Okay. So the higher the acid value, the higher the impurity. The lower the acid value, the lower the impurity. General range is 1 to 5. So what you are going to estimate in acid value? The free fatty acid present in the sample. How you are estimating? By reacting with potassium hydroxide. And what is this range? Range starts from 1 to 5. Higher the range, more impurity. Lower the range, less impurities. Okay. So how to do this experiment? By means of titration. So titrating the oil or fat in an alcoholic medium against standard potassium hydroxide or standard sodium hydroxide solution. So the titrant required here is sodium hydroxide or potassium hydroxide, and the sample contains the fat and oil. You are going to do a titration to estimate the amount of free fatty acid present in the given sample. Okay. So generally, refined oils will be free from any free fatty acid. So refined process means they will not have any free fatty acid. If the oil has undergone some decomposition by means of chemical treatment or by means of chemicals or bacteria, it leads to the release of free fatty acids. So whenever there is a decomposition, your acid value will be increased. Generally, refined oils will not have the free fatty acids. Okay. Then the next one is saponification. So you know already about the saponification. So saponification Generally, it is a process in which the fatty acids in the triglycerides, always remember the fat or the oil, it's a triglyceride. So when it undergoes hydrolysis or decomposition, it will give glycerol moiety and acid moiety. That acid only will be main important to know about that oil. So here also that acid will be hydrolyzed and will react with the alkali. So it will give the salt of fatty acid. So what you are going to do here, you will take known quantity of the fat or oil and you will have to reflux with excess amount of alcoholic potassium hydroxide. So what you will do, you will take the sample in the round bottom flask and you will reflux it with, you will do by refluxing process initially, and you will add the excess amount of alcoholic potassium hydroxide. So what will happen? Saponification reaction takes place. After this reaction, you are going to estimate the potassium hydroxide present in this by means of titration. So the value obtained here is mainly used for the determination of saponification number for the fats and oils. Okay. You can see the example here. Triglyceride undergoes reaction with sodium hydroxide, it forms sodium salt or sodium soap or soap, sodium palmitate. It's a fat or triglyceride which contains palmitic acid. So sodium palmitate is formed here. So this generally the main, see whenever you are learning this analytical constants, you will have to know the significance. When we are talking about acid value, it tell you about the purity of the oil. In case of saponification value, it gives information related to the molecular weight of the sample. And the next one is iodine value. The name itself indicating that iodine is mainly responsible in this reaction. So what it will do, iodine will react with the unsaturation present in the sample. Unsaturation means carbon-carbon double bonds. So in the big chain or in the big, the fat is like long chain. It contains fatty acid and this glycerol moiety. So the big chain will have many double bonds. So wherever the double bonds are present, there the iodine will go and react. So unsaturated compound will become saturated compound. It will become iodo compound. So we are reacting with the iodine molecule. So you can see here, it is defined as the number of milligrams of iodine absorbed by 100 grams of fat or oil under specified conditions. So you will be taking 100 grams of fat or oil and then, or you are taking a sample and you will estimate by this definition wise. So how much amount of iodine is absorbed by 100 grams of fat or oil will be estimated as iodine value or iodine number. In exam if they ask iodine number, also you can mention the same. That's a synonym for this. And the method used here is iodine monochloride method. So what is this method? You will take the sample. Sample means what? Fat or oil. You will dissolve in carbon tetrachloride and then you will add excess of Regis solution. What is this Regis solution? It's nothing but a solution of iodine monochloride mixed in glacialistic acid. Okay? So you are taking the Regis reagent with the sample dissolved in carbon tetrachloride. After that, you will have to do the titration. So whenever iodine is reactive, generally we are using sodium thiosulfate, also called as hypo. Okay? So then you will use starch as external indicator. So this is about the titration. So you can see reaction here. The double bonds reacts with iodine and they will form iodo compound. That's why they are estimating the amount of iodine absorbed by that 100 grams of fat or oil. Okay? So measures the degree of unsaturation of fat or oil. As we have discussed, the iodine will go and react with the double bonds. That means how many double bonds are there, that much iodine is absorbed. So based on the iodine absorption, you can estimate the number of double bonds present in the sample. So this is the main significance of determining the iodine value for a sample. Then, so it's number of grams of iodine that would add to carbon-carbon double bond present in 100 gram of the fat or oil, as we have already discussed. Clear, no? So generally we have discussed that refined oils will not have free fatty acid. Same way, animal fats. Here the matter of animal fats and vegetable fat or vegetable oils. So animal fats will have more number of saturated acid residues. That means They will not have more number of double bonds. If more number of double bonds are not there, more iodine is not absorbed. That means animal fats will have lower iodine value, whereas vegetable oils will have higher iodine number or higher iodine value. Clear, no? This is about the iodine number. So far we have discussed three concepts here. Acid value gives about the purity of oil by release of free fatty acids. Then saponification value will give you the idea about molecular weight of the fat or oil. And iodine value, you will be knowing about the unsaturation